Today we're joined by Yuchi Huang, and he's out in California. We're going to talk about NLP, or Natural Language Processing. Welcome to the show, Yuchi. Would you introduce yourself?
Thank you, Adam. My name is Yuchi Huang. I'm a senior manager of ACTNext, the Research Development Business Innovation division of ACT. At ACTNext, I lead the team of automated content generation in the AI machine learning group. I spearhead research and development on the use of machine learning and AI in various educational applications. Especially, I focus on the research of automated content generation for learning and educational assessment. And in addition, I lead business capture and proposal development, and also serve as PI on different research programs.
You're going to talk about, is automatic content generation text-based? So is that NLP?
Yeah, that's a large portion of that work is based on NLP, and NLP stands for Natural Language Processing. Uh-huh. In NLP, contains natural language. So natural language refers to what we see, what we as humans speak, such as English, Chinese, French. It is not a computer programming language like Python or Java. It focuses on how we can program computers to process large amount of natural language data, such as news, novels, conversations. A machine can handle certain tasks efficiently and productively. So processing and understanding natural language is relatively simple for our humans, but for computers, it's really difficult, and it involves many complex algorithms. Until today, scientists, they have only made very little progress in some specific applications, and the little progress has been made on the problem of true language understanding. So current research is not enough for machine to use language to reason. So let me give some major examples of NLP tasks in the real world.
Okay.
For instance, automatic summarization, which is the process of shortening text content computationally, then to create a summary that represents the most important or relevant information within the original articles. Another example would be machine translation, which automatically converts source text in one language to text in another language. Actually, right now, the application is quite successful, as we have seen, for example, in Google Translator or automatic translator in other platforms. Speech recognition, this is also a traditional one of one application of NLP, which enables the recognition and translation of spoken language into text by computers.
Okay.
The last one I would like to mention is a new one, but very interesting. Right now, widely used by different business. Sentiment analysis of language data, which determines the overall attitude information. For example, positive, neutral, or negative, contained in the text data. Yeah. I have to say, just several years ago, the field of NLP was very difficult. So the core idea of NLP is actually more on understanding and reasoning, which is not the strength of machine learning. Machine learning is more successful in computer vision and speech processing because problems in these areas are more about sensing or to know where, when, and what. But NLP is quite difficult because it contains the entire logic relationship of human languages. But luckily, with the development of deep learning technology, we now have many powerful machine learning models to help the understanding and processing of natural language.
Okay. I'll jump in here. I think, probably like me, many people think of natural language processing as speech recognition or Google Translate, where it is only inputting and deciphering text. And not many people probably think of the automatic content generation or summarization even as being NLP. How separate are these things, that one is an input maybe and one is kind of an output of NLP? And how is that different maybe from, what did you say, content analysis?
So content analysis or other application like speech recognition or machine translation are used to perform the existing text. Those areas are very important because we have tons of very large amount of text data, like speech data, required to be processed. Yes, that's a very large portion. But another very big area of NLP is the content generation, where we can say the text generation. Because in a lot of areas, we need to output, where we need to create a lot of data for people to review, to enjoy. So this is also very important area inside of NLP.
And I've seen bots that can generate kind of nonsense inspirational messages, or there are different bots that rework different phrases or texts into, in my mind, they're always entertaining. But there are actual applications where we use content generation. And the one I know of is for assessment, that you're creating passages that they can create tests and questions and answers and stuff out of.
Yep.
That's the main one. Is that what you're working on in terms of assessment, creating content for test questions?
Yes. So my team and I mainly work on automated content generation. So here, the content in the term of automated content generation could be considered as any kind of educational material that will be used for learning or assessment. It's not only the text, but also other stuff. It includes text content such as items, passages, handouts, computer codes. It also includes multimodal content such as audio or video lectures, cartoons. It even includes interactive contents such as computer games or even virtual reality. Okay. So it could be very diversified.
Yeah. Wow.
Yeah. And furthermore, the word automated does not mean that human work becomes trivial. So in fact, what we hope is that we free people from some tedious work so as to create more content for students faster and better. So that's why the interactive collaboration between people and software is a very important part of our work. Yeah. So among those, all the content generation, different types. Right now, what we are focusing is automated passage generation and item generation. We are also very actively exploring methods for multimodal content generation, especially for videos and graphics.
And in some cases, in this multimodal, are you doing kind of expression recognition, so you can tell if someone is smiling and happy, and you match that to their speech?
Yeah. So actually, what you mentioned, expression recognition, it is widely used in our work. So it will be used applied combined with the text information. So as I mentioned above, it is called the sentiment analysis.
Okay.
That is based on the facial expression or the text information. For example, the chatting content we can obtain in real time. So based on all this information, we can decide, okay, whether this person in front of the camera is happy or unhappy, whether he's engaged or not engaged. All this kind of information is very important for us to decide the learning efficiency or effectiveness in our platform. So this kind of technology is more and more widely used in our different tools.
And you were going to talk about some of the specifics, some of the models, such as GPT2, and you have to bear with me, I don't really know anything about it. So start from that very low level of explaining GP2-based text generation?
So it's quite theoretical model, research model in machine learning. So literally, it stands for Generative Pre-trained Transformer. I have to say, if I use the technical terms to describe, it is a machine learning language generation model built upon the transformer decoder blocks. Transformer is a novel deep learning network module in which a technique so-called attentions is introduced. GPT-2 model is the second generation of generative pre-trained transformer. So at first, it's kind of a transformer model. The attention mechanism I mentioned here may be difficult to understand. So it means that the relevant information of each part of the article can be rediscovered to a greater extent, so we can model the language in computers. In a sense, our human brains do the same thing too. For example, when we do reading and writing, we are constantly looking back for context relevance in the text. So this is also can be understood as attention. So in the generative pre-trained transformer model, this kind of algorithms were used repeatedly to get a better understanding of the context. So in layman's term, GPT-2 model is a language model to predict next word or a next sentence, next sequence of words given some input text. So the language generated by this model is very coherent and very close to human language, as we have seen in different experiment validation. If you use poems to train this model, it can produce poems. And if you use songs to train this model, it can be used to compose and write lyrics. So it's very promising and very interesting. But also, it has also some problems. But if you would like to know that.
Yeah, and is it related to the predictive text when I'm typing into my phone? It's predicting the next word that I'll use. Is it similar to that?
Yeah, it can be used to predict what you want to input in the following context. For example, when you type, I'm going to write, and here maybe some menu will jump out to show you, okay, like email or reports or something like that. Okay. So basically, all this kind of information are trained. It will like present to you based on the previous training data. This is a very obvious usage of GPT-2, but it can be also used in more complex situation like legal document writing or narrative story writing, something like that. Yeah.
So if you trained this GPT-2 model on legal documents, then you would you couldn't use a poem trained one to write a legal document or vice versa. You'd want to train it with this legal contracts and things like that, right? Is that how it works? Because I'm just trying to figure out.
Yeah, correct. You are very right. To train a model, a GPT-2 model on specific task, we should have a lot of training data to fit in to the system. So if we are going to use the GPT-2 in a specific domain, you should have a lot of training sources from that domain to provide. Okay. So to get a better result.
And if you were going to, I'm just thinking out loud here, if you're going to train it to write legal documents, would you train it first in just language in general, or would you just go right to legal documents and that's all you would train it in? Do you know what I mean? Would there be like a base, or is it you want it to be good at legal, so you just train it with legal? I don't know.
So this is actually a very good question. So in the domain of computer vision, what we do is that we at first to train the model in a very large language material corpus. Okay. For example, like Wikipedia. Okay. Or some like all kinds of text we can get from the internet, from one web page to the other. We use all this kind of information to train the model. That is, in a way, this model becomes a very like a person have all kinds of different knowledges. Mm-hmm. And after that, we will get some specific domain training corpus to train on, which we call fine tuning. Like we teach a student, at first we teach all kinds of different domains knowledge to that student. And after that, to train him or her to become a like domain specialist, we start to teach the students very specific domain knowledge. So it's kind of that kind of process.
Okay. And then you said you were going to go into some of the drawbacks or challenges.
Right now, GPT-2 has a lot of problems. The major problem is that although the content generated is coherent or looks like human created text, the major problem it creates, the content, and those content may be lack of factual support and contains a lot of wrong information. Even though the sentence seems to be true, to us, but if you do some digging, you will find out it's actually wrong. Previously, when I see a sentence created by GPT-2 said, Iranian president, blah, 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 has attended this conference. And when I go back to search that name, I found non-Iranian presidents have that kind of name. No, not in the history. So we cannot use this kind of information directly into our testing or other articles will be published publicly. We should use them very carefully, especially for those scientific articles or those articles will be based on truth, like history. We should need to check back the output results very carefully. Right now, we can use it to create narratives to telling stories. So that don't need facts to support them. That's entirely okay.
Okay. So in every case, you can't just trust it to create a passage or a summarization. You're checking it. You're coming back to check it. Human checkers.
Yeah, we have to check that.
Yeah.
Yeah, we have to. Yeah.
Can we talk about Sphinx? So how are we using GPT-2 in Sphinx? And are there other programs?
Right now, we do use GPT-2 in Sphinx to generate new sentences based on part of draft, which has already been composed. In the following, we also may use GPT-2 and other technologies to perform text style transformation. So style transformation means if we generate like one piece of the article, we would like to transform it into, for example, so-called ACT style, because when we ACT use an article in testing or learning, we have some format or requirements to follow. For example, how many words for the whole article, how many paragraphs, and the word difficulties for different grades of students, something like that.
Yeah.
We have to do this kind of transformation. We will do some development and research inside of GPT-2 to fulfill this change. We can also use GPT-2 in some simpler applications. For example, to recommend words or phrases that will be used to complete a sentence, like you mentioned before in that example. When the writer typing something, and some words or phrases will jump out automatic. It can be also used to evaluate whether a written sequence of text is coherent, because it's a language model, it's a statistic model. If you put in a sequence, it can tell you the percentage this model thinks whether it's coherent. So this is also a very good tool to decide whether a piece of text is written coherently by a student. So we have a lot of applications to go by using GPT-2.
What strikes me is that we're using it for both generating, and you're saying you could use it to analyze sentences.
Yeah.
Besides GP2 models, what else do you use? What other techniques or NLP practices can we talk about?
Besides GPT-2, we also use other deep learning models, because deep learning is very hot during these years to extract features for various applications. For example, we use another model which is called BERT.
Do you use BERT?
Let me search what BERT stands for.
Oh, okay.
I don't remember actually. BERT stands for bidirectional encoder representation from transformers. So actually, it's another model deriving from transformers. As I mentioned before, transformer is a deep learning model. The difference between BERT and GPT2 is that GPT2 is like a forward-moving network. That means you input something, it will output something. It always generates something after what you have input.
Okay.
But for BERT, it's different. BERT is like a kind of language model. When it performs training, it will get rid of some sentence or some words from the sentences. Basically, the training process tries to predict the words, whether these words predicted aligns with the original words there. So it did this kind of like prediction. So after training, it can predict some very, very good words to fill the gap. And at the same time, in this process, we can get very good features from the corpus we train. So in that way, the features of the sentence or piece of sequence can be used for, say, like text classification or to predict the sentiment of the sequence we input, something like that. So the usage of BERT is more on analysis of the text, not generation.
Oh, okay. Huh. Okay.
Yeah. This is like work based on deep learning and other NLP tools we use. For example, we use a lot of tools for topic extraction, try to extract major topics from the articles. Topic clustering, we try to cluster different articles into different groups so people can read them. For example, they are going to read a specific domain. This kind of clusters can be generated automatically, so they don't have to do the classification by hand. Yeah. So a lot of applications and algorithms are used in NLP.
Yeah. And so let me ask you about what are some of the challenges of working with NLP?
The challenges working in a domain of NLP is just like the other domains of machine learning, basically. So at first, you have to look into the data very carefully. So it's not just like you collect the data and you choose a model and you run the model and get results. It's not like that. So you have to use knowledge of data science to carefully review the data we collected. Do we need to do some cleaning on the data to format that data into specific patterns so we can use, and sometimes get rid of the noise? And then we have to choose appropriate models. There are so many different models in NLP. We can adapt to the data. Different models have different capability, or we need to try to think through the problem and select the right model to use on the data. Yeah. And another thing is that before implementing any algorithm, we should think about the capability of the current algorithms. Sometimes we should know that computers cannot do anything. It has limitation. We need to actively incorporate the ability of human beings. So we make the interactive algorithms. So in that way, we can get the combination of the advantages from both sides, the human and computers. In that way, we can enlarge our capability as much as possible. So this is what we have done in the tool of Sphinx. That is, Sphinx is a tool to combine the strengths from both human and machine learning. Sometimes we need the human to make decisions based on the information provided by machine learning algorithms. So the advantage of machine learning is that it can process very large amount of data to get some vital information from that data. The advantage of or the strength of human is that we can base on the information to make the right decision. I don't know how to summarize or call it in the field of machine learning, but this is sometimes the best way to handle the practical problems.
What are some of the other challenges of NLP or working in machine learning in general?
the most biggest challenge for machine learning is to perform the reasoning, and very little progress has been made in this domain. Yeah, try to find the logical inside of text or other sensing data like images, videos, to make like very complicated reasoning or prediction. Yeah, in this domain, we haven't made a lot of progress, and this is always the key focusing for the frontier machine learning research.
How do you get past that, or what's it going to take to get into that?
Well,
high
that
level?
is really hard to say.
Yeah.
Yeah, that is really hard to see. We haven't seen any like potential algorithms or models can fulfill that.
Yeah.
Apparently, deep learning, the current stage of deep learning cannot do that. How can we reach that goal? We don't know.
Yeah. Okay. That's what I thought. But I thought I'd ask, and maybe you had the answer for me. Let's see.
Maybe quantum computing, but we don't know.
We'll do this again in 3 years, and then maybe I'll have an answer by then. I had this.
Yeah, maybe 30 years.
30. Okay.
I'm just kidding. Yeah.
Somewhere between 3 and 30 years. What is cross-validation? Is this a good question, or is it too technical?
So I guess you want to ask what is CV, right?
Yeah.
Yeah, CV could be understood as cross-validation, which is an important technical term when we do experiments, validation on data. So cross-validation is like that. You chop the data in, for example, in 10 pieces, and you use like 9 pieces to train and another piece to validate. That is, you will like use the one piece to fit into the model to generate the prediction, and you compare that the prediction to ground truth. You cannot do just for one time, because you have like chopped that data into 10 pieces. You have to do every piece of that data use that for prediction and the rest for training. You do this for 10 times. So this is called tenfold cross-validation. So this is a technique we use in experiments to validate our ideas, whether this is really good or not on the specific data set. Yeah. Actually, I thought you are going to ask what is CV.
Oh.
So CV, actually, it is more widely used to refer to computer vision. Yeah, because I have been engaged into the research and development of computer vision since I started my PhD study. So, yeah, CV is more on computer vision.
And that's how you got to know Saad?
Actually, I know Saad from publications. I read his papers previously because I have, as I mentioned, I was a computer vision researcher. I studied computer vision since I was in my PhD program, and later in the first several years of my industry experience, I have done a lot of work on face recognition, target detection and tracking, object recognition and search. After several years, I found out I need to find a specific domain to use my expertise. So one domain I can think I like, and I think different machine learning expertise can be used is education. And I found out Saad is working, at that time was working at ETS as a senior research scientist. And in his group, there is a position. So I applied for that position and become an NLP and computer vision research scientist in ETS. That's the starting point when I worked with Saad.
Oh, okay. So you've known him for a few years.
We have worked together for a few years, and
But he came to ACT first, and then you joined a year later or so?
After he joined ACT, after he decided to join ACT, he asked me whether I would like to join ACT. So I think this is a good opportunity for me. Yeah. So I choose to join.
Good.
And I think this is the right decision.
Good. So let's talk about you. Where did you grow up, and then where did you go to school, and what got you into computers?
I grew up in China. I was born there. I was born in a very small town alongside the Yangtze River, the biggest river in China.
Yeah.
I finished my childhood, my primary school to college in China. I went to Beijing University of Astronautics and Aeronautics in Beijing, in China. And after that, I went to United States to start my PhD studying in Rutgers University for computer science. Yeah. Previously, when I was a college student, my major is automatic control, basically a subfield of electrical engineering.
Okay.
Finally, I found out computers will rule anyway for automatic control or electrical engineering. So that's why I transferred to computer science to learn more about machine learning, computer vision, and later NLP.
Was there something you remember growing up that you said, I would like to go into this? At that time, it was electrical engineering.
So I don't even know that I'm going to be a scientist when I was young, but I like reading. I like studying. I enjoy the process of learning very much. I like to swim in the sea of knowledge. So maybe that kind of interest and guide me to the way of research and my current career. So I guess that's the reason. I'm also a huge fan of sci-fi movies, so maybe that's also the reason.
Yeah, good. What's the best part of your job? How about that?
Actually, so my daily routine is like I will be doing a lot of research reading. I will do discussion with my team members. I will discuss the projects during the meetings, regular meetings. I will do project management work, paper writing, and even sometimes I will still do some prototyping coding. But now as a manager, I need to spend more time thinking about the directions of different research problems in the team and also perform project management with the team members.
Yeah.
So I like this kind of work paradigms, which allow me to get in touch with more businesses and consider issues from a more comprehensive perspective.
Good. That's good. Okay. So thank you, Yuchi, for joining us. I hope you had fun.
Thanks for having me, and I really appreciate I have this opportunity to explain a lot of problems in machine learning and NLP. If you have any questions, please let me know. Thank you.
Thank you, Yuchi.